Last episode ended on a promise. To authorize across services, we said, you don't reach across the network. You keep a local read model, a copy of just the data you need, kept current by events. But that only moves the hard question. How do those events get from one service to another, reliably, without ever losing one? Because the obvious answer, save my data, then publish an event, has a subtle, nasty bug. Let's find it and fix it with a pattern called the Outbox. Here's the trap. Your handler does two things. It saves the change to its database, and it publishes an event to a broker for other services. Two separate systems, two separate calls, and no transaction spans both. So picture a crash in the gap between them. If you saved first, the data is committed, but the event never went out. Other services will never hear about it. It's silently, permanently inconsistent. Flip the order and publish first, and a crash leaves you worse off. You've announced an event for a change that never actually committed. This is the dual write problem, and you can't solve it by being careful. You need a different shape. The fix is beautifully simple. Instead of publishing to the broker inside your handler, you write the event into an Outbox table, a plain table in your own database, in the very same transaction as your state change. Now there's no gap. Either both the data and the event commit together, or neither does. They're atomic because they're one transaction. Then, separately, a background relay reads new rows from that Outbox and publishes them to the broker, and it keeps trying until it succeeds. The event is durable in your database the whole time, so a crash just means the relay picks up where it left off. Save is atomic, delivery is at least once. In Trellis, your aggregate raises a domain event as usual, and the Outbox captures it in that same commit. But a domain event is internal. It's your private language. Other services get a separate, public contract produced by a translator. Here's the members one. It's just an event handler. It takes the internal member-invited event and adds a public integration event to the collector. Two things to notice. The ID is deterministic, derived from the member, not random, which will let consumers dedupe. And the payload is primitives only. IDs, a role, a timestamp, no rich objects, and deliberately no email. The wire contract is small, stable, and free of private types. Let's watch the whole producer side. Your member aggregate raises its event. In the same database transaction that saves the member, the event lands in the Outbox, so they commit together or not at all. After the commit, the relay wakes up, reads the new Outbox row, and publishes it to the broker, here, Azure Service Bus. If the broker is down, the row stays in the Outbox and the relay retries later. The event cannot be lost, and it cannot be sent for a change that didn't happen. That's the guarantee the Outbox buys you. Two consequences worth stating plainly. First, at least once means duplicates are normal, not exceptional. The relay retries until the broker acknowledges, and a retry after a slow act sends the same event twice. That's not a bug to prevent. It's a reality to embrace. And it's exactly why the ID was deterministic. The consumer can recognize it has seen this event before and skip it. We build that side next episode. Second, because this contract crosses a boundary and is consumed by teams you don't control, it's primitives only and versioned, a stable, public shape. When it needs to change, you add a new version rather than breaking the old one. Small, stable, versioned, a contract other services can rely on. So, eventual consistency, done right. You can't atomically write to your database and a message broker, so don't try. Write the event to an Outbox in the same transaction as your data, and let a relay deliver it afterward, at least once. A translator turns your internal domain event into a small, versioned, primitives-only contract with a deterministic ID. The change can never be lost and never sent for something that didn't happen. Next time, we're on the other side of that broker. How a consumer takes these at least once events and turns them into a correct, idempotent read model. Subscribe, and I'll see you there.